This video is on the least common multiple, abbreviated LCM. Sometimes we say lowest common multiple. You'll see that also. The least common multiple, or LCM, of two natural numbers is the smallest number that is a multiple of both numbers. Natural numbers just means the numbers 1, 2, 3, 4. You know how we naturally learn how to count. Those are called natural numbers. The whole numbers is just like the natural numbers, except we start with the number 0. So whole numbers is 0, 1, 2, 3. Natural numbers is 1, 2, 3, 4. Later on we'll add more to those, like rational numbers. Rational numbers are all the fractions, 2/3, 1/2. And then we talk about positive integers and negative integers, which means, positive values and negative numbers like -7. Anyways, I got a little off track. I just want you to know about natural numbers. Natural numbers just means the numbers 1, 2, 3, and so on. So the LCM is the smallest number that is a multiple of both numbers. Okay, so right now we're just talking about two numbers, but we could also talk about the lowest common multiple of 3 numbers or 4 numbers. It's the same thing. Okay, so let's take an example. Find the LCM of 6 and 8. Okay, well, let's take the first number, 6, and let's create a partial list of multiples for those numbers, for 6 and 8. Multiples just means that we're going to multiply 6 by the natural numbers, 6 times 1, 6 times 2, 6 times 3, etc. So I made quite a list here, up through 78 for 6 and up through 8. For 8, the list goes up to 80. But it goes on forever. That's why I put ... just to say that it goes on forever. So this is 6. If you increase it by 6, you get 12. Increase it by 6, 18. Or we could think of this as 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, etc. Okay, the LCM, lowest common multiple, is the smallest number that appears in both lists. Think about that. Least or lowest. Common, meaning the same number that's common. Multiple. So we want to look at these two lists and find the smallest number that appears in both lists. Can you find the smallest number? Right, 24. That's it right there. That is the lowest common multiple. Now also note, there are other common multiples, such as 48 and 72. See that 48 is on this list in both of them? So is 72. And if we keep going, we'll find other common multiples. But 24 is the lowest common multiple. Okay, so this is one method for finding a least common multiple. Let's do another example using this method, and then we'll talk about another method without writing out a list of multiples. Okay, find the least common multiple of 10 and 12. So I made a list here of common multiples. I made a list of multiples of 10, 10, 20, 30, 40, 50, 60, 12, 24, 36, 48, 60, just far enough to go until we found a common multiple. And that common multiple is 60. So the LCM of 10 and 12 is 60. Okay, finding the LCM is part of the process to adding and subtracting fractions with unlike denominators. So it is very important. That's what this is. Sometimes we don't realize, why are we doing this? You might be asking that all the time. Why are we doing this? And if we want to be able to add fractions, this is what we need to know how to do. We need to know how to find the LCM. So writing down a list of multiples, doing what we did, that's okay. It works. We found the lowest common multiple for 10 and 12. But what if the numbers are large? So writing down a list of multiples is an okay method as long as the numbers are relatively small. But what if we need to find the LCM of 84 and 90? Then making a list of multiples until we find a common multiple is going to take some time. Think about that. If our numbers were 84 and 90, let's see, 84, and then 84 times 2 is 168. And then 84 times 3, well, I can't do that in my head. I have to go ahead and work it out. So that's a process. And actually, the answer to the LCM of 84 and 90 is like 1,260. So it's going to take a while to get there. Fortunately, we have a better method. Okay, so finding the LCM when the numbers are small, that's good. But when it's larger, we have another method. Also, the proper process is what we're going to learn later on when we get to algebra. Here we're just talking about numbers, but when we get to algebra, we're going to be talking about x's and y's and binomial factors like x plus 3. So we need to have a proper process that we could build on for algebra. Sometimes we could look at a number and say, oh, I know what the answer is in my head. That's great, but we want to be prepared for all types of problems. Okay, let's get started. This is called the prime factorization method for finding the LCM, least common multiple. So on a previous video, we've talked about prime factorization. If you need to review, you might want to go back and review prime factorization. Step 1. Find the prime factorization of each number. So that's the tree. We learned the tree method. You could also use the division method. Either method is fine. Step 2. Identify the prime numbers. The LCM is equal to a product of these prime numbers, using each prime number the greatest number of times that it occurs in any one of the prime factorizations. That's a lot to take in right there. This product is the LCM. So why don't you pause the video, make sure you write down this step, this procedure, and this is the tricky part. It's going to be a product of prime numbers, and each prime number is written the greatest number of times that it occurs in any one of the factorizations. And then we're going to multiply. Okay, ready? Let's do it. Find the LCM of 15 and 24. So it's a number that these numbers will divide evenly into. So it's bigger than 15 and bigger than 24. Step 1. Find the prime factorization of each number. So let's write down the 15 and 24 and find the prime factorization. I'm going to do the tree method, but if you wanted to use the division method, that's fine. So 15 is 3 times 5. You might want to pause and then work out the other one. 4 times 6. 4 is not prime, so we'll break down that 4. And 6 is not prime, so break down the 6. Now I always like to write down in a row. So 15 is 3 times 5. And 24 is 2 times 2 times 2 times 3. Okay, remember, pause the video if you're not at this point yet. Okay, let's keep going. Step 2. write the LCM equals below the prime factorization of each number. So let's write down LCM equals. Okay, so just write down LCM. Now, consider each prime number. Write it the greatest number of times it occurs in any one factorization. So, the numbers that we have here are 2, 3, and 5. Let's start with 2. We're going to write it down the greatest number of times that it occurs in any one row. So the number 2. What's the greatest number of times that it occurs? It occurs 3 times in the 24. So write down 3 2s. 1, 2, 3. Now let's look at the 3. You're going to write it down the greatest number of times it occurs in any one row. You're not adding all of the 3's up. You're not going to write down all of them. What's the most number of times it occurs in the top row? Once. I said that wrong. How many times does it occur in the top row? Once. How many times does it occur in the bottom row? Once. What was the greatest number of times it occurred in either row? Just once. So the number 3, it occurs once. So only 1 3. Not 2 3's. Do not write 2 3's here. Only 1, because that was the most number of times that it occurred in one row. Now the number 5. What's the greatest number of times the 5 occurs in one row? Just once. So now we can multiply that. So now multiply, and this is the LCM. So we're going to have 3 2's, 1 3, and 1 5. So you can multiply in order. 2 times 2 is 4. 4 times 2 is 8. You could also, sometimes I like to find a 10. See, a 2 and a 5 is 10. And then multiply the other numbers. 2 times 2 times 3 is 12. So 12 times 10 would be 120. That's your LCM. So if we were adding fractions, this is going to be our LCM. That's what we're going to make our new denominator when we get to that section. Okay, let's do another problem. Find the LCM of 14 and 20. So you might want to pause the video and then go ahead and work on it. At least find the prime factorization for 14 and 20 right now. Okay, so let's get started. Find the prime factorization of each number. So we're going to write down 14 and 20. And then we're going to find the prime factorization of 14. Let's see, that's 2 times 7. 20, we could use 4 times 5. And then 4 is 2 times 2. 5 is prime. So now listed in 2 different rows here. So 14 is 2 times 7. 20 is 2 times 2 times 5. Now write LCM underneath here. And then you're going to consider each prime number. Write it the greatest number of times that it occurs in either row. So let's start with 2. What's the greatest number of times it occurs in either row? Well, it occurs once in the top row, twice in the bottom row. So the greatest number of times the 2 occurred was twice in the bottom row. So in the 20, it occurs twice. Now the 5. So write down 2 2's. Now the 5. What's the greatest number of times it occurs in one row? Just once. So 5 in the LCM. The next prime number is 7. What's the greatest number of times the 7 occurs in one row? Once. And then multiply that, and that will be your LCM. 140. All right, let's do another example. 3 numbers this time. So it's still going to be the same process. Prime factorization, LCM equals, and then consider each prime number and write it the greatest number of times it occurs in one row. All right, prime factorization. So you might want to pause and work on it, and then come back to us when you're ready to see the worked out solution. Okay, so 12, 30, and 70. 12 is 2 times 6, and 6 is 2 times 3. Now the 30, and you might use 3 times 4 here. Again, the result will never matter what you start with. The only numbers you don't want to use is 1 and the same number. Okay, 5 and 6, 6, 2 and 3, and then 70, yeah, 7 and 10, and 2 and 5. So 12 is 2 times 2 times 3. 30 is 2 times 3 times 5. And 70 is 2 times 5 times 10. I like to put the numbers in order because I'm going to be looking at them in detail. Make sure you have everything correctly. Math is a long process. These problems are always a long process. It only takes one mistake to get this wrong. So everything has to go right. You have to do this part right. Now, let's write LCM below the factorization. So just write LCM equals. Now we're going to consider each prime number, and you're going to write it the greatest number of times it occurs in any one factorization. So start with the number 2. What's the greatest number of times it occurs in any one factorization? What's the greatest number of times it occurs in any one row? So the 2, it occurs how many times in the top row? Twice. How many times in the middle row? Once. How many times in the bottom row? Once. So what was the greatest number of times that it occurred in any one row? Twice. So the 2, it occurs twice. So we're going to have 2 2's. 2 times 2. Now the next number is 3. What's the greatest number of times the 3 occurs in one row? Once in the top row, once in the middle row, none in the bottom row. So the greatest number of times it occurred was once. The next number is 5. What's the greatest number of times it occurs in any one row? None in the first row, once in the second row, and once in the third row. So what was the greatest number of times that a 5 occurred? That's right, once. Excuse me. And now the next number is 7. What's the greatest number that occurs in one row? Just once. Now multiply that, and that's going to be your LCD, or LCM. Okay, I'll see you here for the next video.